Lesson 26, Probability Distribution. Example 10. A couple plans on having 3 children. Determine the probability distribution for the number of girls this couple could have, and calculate the corresponding mean and standard deviation. Well, first we're going to determine the probability distribution. To do this, we'll need to come up with either a table, a graph, or a formula, which provides the probability for every possible outcome. In this example, we'll construct a probability distribution table. That is, a table has 2 columns, one listing x, the random variable, and the second one listing p sub x, the probabilities. In this case, the random variable x is focusing on the number of girls this couple could have out of the total of 3 children. So x is the number of girls in a 3-child family. So what are all the possible outcomes? Well, in a 3-child family, the lowest number of girls that can be in that family would be 0, no girls. And the highest number of girls in a 3-child family would be 3. So all the possible values of the number of girls in a 3-child family would range from a low of 0 to 1 to 2 to a high of 3. So here's x, all the possible outcomes. Now we need to calculate p of x, the probability of getting each of these outcomes. So let's start with 0. To find the probability that there are 0 girls born in a 3-child family, we'll need to count all the possible outcomes. Well, in a 3-child family, there's a firstborn, a secondborn, and a thirdborn. Now the possibilities that result in an x equals 0, that is, none of them are girls, is only one instance. That is, a boy is the firstborn, a boy is the secondborn, and a boy is the thirdborn. When all 3 children are boys, none of them are girls. So there's only one way to have no girls in a 3-child family. Next, to find the probability that x equals 1, that is, there's just one girl in the family, you could have a girl born first, a boy born second, and a boy born third. In this instance, there's one girl, and the remaining children are boys. But this isn't the only way this can occur. This instance has the one girl being the firstborn. Another occurrence could have the one girl being the secondborn. So there's a boy born first, the girl is second, and the boy is born third. But there's another occurrence. That is, the one girl could be the youngest or thirdborn. So we have a boy first, a boy second, and the girl third. These are 3 different possibilities that all result in an x equals 1, one girl born out of the 3 children. So there's a total of 3 possible ways x could equal 1. Now for x equals 2. That is, the probability that 2 of the children are girls can be found this way. Well, if there are 2 girls in the family out of 3 children, that means there's just one boy. And that one boy could have been the youngest, meaning the first 2 were girls. So here we have a girl first, girl second, and the boys third. That's just one arrangement. There are other arrangements. That is, the one boy could have been the middle child. So there's x equals 2 girls, girl first, girl born third, and the boy is born second. Or we could have the one boy be the oldest child. We have a boy, and then a girl, and a girl. All of these 3 cases have x equals 2 girls and just one boy. It just happens there's 3 ways to do that. The one boy could be the firstborn, or the secondborn, or the thirdborn. So we count a total of 3 possibilities that x could equals 2. That is, there's 2 girls in the 3-child family. Now finally, to find the probability that x equals 3, that is, all 3 children are girls, there's only one way that can occur. That is, the firstborn is a girl, the secondborn is a girl, and the thirdborn is a girl. There's only one way to have all x equals 3 children girls. So now we've counted all the possible outcomes. Now, to find the probabilities, we take this count and divide by the total number of possible outcomes. And assuming that each of these 1 plus 3 plus 3 plus 1, which equals 8 outcomes, are equally likely, we can then divide these frequencies by the total of 8. So now we have our probability distribution for the number of girls born in a 3-child family. Now to calculate the corresponding mean and standard deviation. We can use our Ti84 calculator to do this. So enter the probability distribution into the lists by pressing Stat, Enter, and we can clear out old data to make room for new data. And starting in list 1, we enter the values of the random variable x. 0, enter, 1, enter, 2, enter, 3, enter. And then under list 2, we enter in the corresponding probabilities. 1 divided by 8, enter. 3 divided by 8, enter. 3 divided by 8, enter. 1 divided by 8, enter. And now we can calculate the mean and standard deviation by pressing Stat, right arrow to Calc, Enter to select one of our stats. The X data was in list 1, comma, to separate from the probabilities in list 2. Enter. So now we could read off the calculator screen the mean and the standard deviation. When calculating the means and standard deviations based off probability distributions, we're actually dealing with the population, that is 100% of all the possible outcomes. So we will use the population symbols for mean and standard deviation. So mu sub x, the mean, is equal to 1.5. And the standard deviation, sigma sub x, it rounds off to about 0.9. So there we have it. We have the probability distribution for the number of girls born in a 3-child family, along with the corresponding mean and standard deviation.